This is the ARMEE automatic respiration management exclusively for emergencies. It's just a simple device, 2 panes of plastic attached together with particular channels carved out. It has 3 ports, one that leads to the lungs, one that leads to the atmosphere, and one that is the input, where a high pressure stream of air comes in. This device does one thing, and does one thing only. It takes a high pressure stream of air and switches it from one side to another. It does this at pressures that are determined by these set screws for high and low pressure control. And then we can also partially close the exhale port to set a particular timing for this. Here's how it works. A high flow rate of air comes through here and shoots out through one channel into the lungs. As the pressure builds up in the lungs, that propagates back through here and creates a flow that goes through this channel. Once it's high enough, and we can set this with this PIP pressure screw, it'll then push this central stream of air to the right, causing it to go of the exhalation port. As the high pressure air shoots out the exhalation channel, the air in the lungs is sucked out, and eventually it reaches a low enough pressure that the difference between this high pressure side and this now low pressure side creates a flow from the right to the left, pushing the high pressure stream back to the lungs and restarting the cycle. And here's the device in action. The gray piece, no bigger than a deck of cards, is all that's really needed here. It's hooked to 2 tubes, one to a constantly flowing air source and one to a test lung with some weight on it. This is a single piece FDM 3D printed design pulled off by our teammate Artemio Mendoza. Anyone can download it and test it out from our open source GitHub. Please do not use it on actual patients though. We are currently conducting professional tests with better lungs, emergency valves, and sensors, but this can at least give you a picture of the simplicity of this design. And here's another design by Jake Lunde, who uses a different fluidic concept to perform the same timer effect. You can see the different pressures reached in the liquid pressure sensor on the left. We call this measurement device a manometer, and it can be made by anyone with simple tubing and some water.